Hi students, welcome to my channel Biochemics with Ajay Amanar. Today we will discuss a few multiple choice questions from a chapter Light, Reflection and Refraction. In this video we are going to discuss exclusively multiple choice questions which appeared previous year's examinations. So don't skip this video till the end of this. After watching this, don't forget, please like it, share it and subscribe it. So here is our first question. When a plane mirror is rotated through a certain angle, the reflected ray turns through twice as much and the size of the image. Option A, the size of the image is doubled. Option B is halved. Option C, it becomes infinite. Option D, it remains the same. So see my dear children here we are dealing with a plane mirror. So when plane mirror is rotated through a certain angle, so what would be the reflected angle, right? That means whether it doubled or halved, or it becomes infinite, or it remains the same. See this picture here. If you stand in front of a plane mirror, actually we know that a mirror form mirror properties here. So the size of the image is same as size of the object, and the distance between the mirror and image is equal to the distance between mirror and object. So with this concept we will find out solution. Your answer is that remains the same. Option D remains the same. Image remains the same size, same distance from the mirror. Second question. If an object is placed symmetrically between two plane mirrors inclined at an angle of 72 degrees, then the total number of images formed is. See my dear children, here there are two mirrors, plane mirrors. They should be placed symmetrically between, objects should be kept between these two mirrors symmetrically, and these two mirrors are arranged inclined at an angle of 72 degrees. Now, then we have to calculate the total number of images found in this situation. Option A, 5, option B, 4, option C, 2 images, and option D, infinite. Now let's see the answer here. See, there is a formula to calculate number of images formed when two plane mirrors are arranged inclined at each other with a certain angle. If you see this formula, number of images is equal to 360 upon theta minus 1, right? If you use this formula, you will find out number of images formed in this situation. So here theta is given, that is 72 degrees. If you substitute this value in this formula, 360 degrees upon 72 degrees minus 1, then 360 minus 7 by 72, that gives you 5, minus 1, it is 4. So total number of images formed when two plane mirrors arranged with an angle of 72, or option B, it's a 4 images will be formed. 4 images will be formed. Third question, which statement is true for the reflection of light? The angle of incidence and angle of reflection are equal. B, the reflected light is less bright than the incident light. Option C, the sum of the angle incidence and reflection is always greater than 90 degrees. Option D, the beams of the incident light after reflection diverge at unequal angles. My dear friends, we know that mirror loss of reflection we have. Angle of incidence is always equal to angle of reflection, and incident ray, normal and reflected ray are on the same plane. This we know very well. If you observe this picture, you will understand angle of incidence is always equal to angle of reflection. So your option is A. The angle of incidence and angle of reflection are equal. Next question. The focal length of a plane mirror is infinite. Infinite. Plane mirror focal length is infinite. Right. Fifth question. The image shows the path of incident rays to a concave mirror. See here, it's a concave mirror given which has a focal length, which has center of the curvature. Object is kept on principal axis. We know that we already studied this one. When object is at beyond the center of the curvature, the image formed between, we know that we'll see. Where would the reflected rays meet for the image formation to take place? Behind the mirror, between focus and optical center, between center of the curvature and focus, and beyond C. Let's see the option. Option C, that is between C and F. C and F, between center of the curvature and focal length. So when object kept at center of the curvature, image is formed exactly below the center of the curvature. The image formed here is real and inverted image. Even in this case, in this given case, the type of image formed here is real and inverted, and the size of the image is smaller than that of object. Question. A beam of light incident on a plane mirror forms a real image on reflection. The incident beam is a beam of light incident on a plane mirror forms a real image on reflection. The incident beam is it's a parallel. Incident beam is a parallel. Incident beam is convergent. Incident beam is divergent and not certain. Your option B, it is convergent. The incident beam is a convergent. Convergent. Question. An object is placed at a distance of 40 centimeters in front of a concave mirror of a focal length of 20 centimeters. Then the image formed here is option A, virtual and inverted, option B, real and erect, option C, real inverted and the opposite size of the object, and option D, real inverted and of the same size that of the object. Now you see, children, these kind of questions, whenever you see these kind of numericals, you have to check for any clue, any keyword in this one, right? The first thing is here, it's a concave mirror which is converging mirror. We know that concave mirror always forms a real and inverted image except in one situation. And here focal length is given. Focal length is 20 centimeter, and when focal length is 20 centimeter, but object is placed at 40 centimeter. Here, by seeing this, we can calculate the center of the curvature. When center of the curvature is exactly double to its focal length. So here, focal length is 20 centimeter and its center of the curvature is 40 centimeter. So object is also placed exactly at 40 centimeter. When object is placed at center of the curvature, the image is formed exactly below the center of the curvature and whose size is same as object size, right? This is the clue we have to calculate. We have to found, right? Now your answer is option. Here you see, if you see this picture, object is here. If you just bring these numericals or values in this picture, focal length is 20 centimeter, object is kept at 40 centimeter. That means center of the curvature. Center of the curvature. So image is formed exactly below the center of the curvature of same size. So your option is option D, real, inverted, and of the same size as that of the object. Right? Right. A student conducts an experiment using a convex lens. He places the object at a distance of 60 centimeter in front of the lens and observes that the image is formed at a distance of 30 centimeter behind the lens. What is the power of the lens here? So here options are given like option A 0.005 diopter, option B 0.05 diopter, option C 5 diopter, and option D 50 diopters. So my dear children, we know that the power of lens is given measured in terms of diopters, right? So if you observe this this numerical, here we have a convex lens. We know that is converging lens. The image is formed behind the lens here. So an object is placed in front of lens, that is 60 centimeter away from the lens, and on the other hand image is formed that is 30 centimeter away from the optical center, right? Now we have to find out the power of the lens. To find out the power of the lens, we need the help of focal length. So by using these two clues, we have to calculate first the focal length of that lens, then we have to convert focal length into power. So if you observe this picture, here object is given kept at in front of lens, that is 60 centimeter away. It's a candle is an object here, and on the other hand, other side behind the lens, image is formed that is just on a screen that is just real and inverted. If you observe, the distance between lens and object is exactly almost double to the length of the image so formed here. So from this we can use a lens formula, and we can find out focal length of it. Lens formula, you know that 1 by f equal to 1 by v minus 1 by u, right? If you substitute these values in that formula, you will get a focal length of 20 centimeter of this lens. So actually power, to calculate power, 1 meter is equal to 1 meter. We generally measure focal length in terms of meters while calculating power of the lens. So we have to convert this centimeter into meter. That means 20 centimeter is given as 0.2 meters. 0.2 meters. And focal length formula, we know focal length and power formula, power equal to 1 by f. If you keep 1 by 0.2, that you will get 5 diopters, right? Here your answer is option C, it's 5 diopter. An image of an object produced on a screen which is about 30 centimeter using a convex lens. The image produced is about 3 times the size of the object. What is the size of the object? What is the size of the object, right? Here you see an object image is given. Image size is 36 centimeter, and it is 3 times bigger than the size of the object. That means object is 1. Object taken as 1. Image is taken as 3 times larger. If object is 1 centimeter, image will be 3 centimeters. If object is 1 meter, image will be 3 meters, like that. So what is the size of the object? So here ratio is given, that is the object to image size, image to object size is, that is 3:1. From this ratio, we have to find out the size of the object, right? We need the help of magnification formula here. Your options are given like this: option A 12 centimeter, option B 33 centimeter, option C 39 centimeter, option D 108 centimeter. Your option is option A, it's a 30 centimeter. 30 centimeter. If you use magnification formula, that is height of image by height of object. See here magnification is given, that is 3. That is 3 is given, and image of object, image is given 36 centimeter image. So 3 equal to 36 by height of the object. Height of the object. Height of the object equal to 36 by 3. That gives you 12 centimeters here. Next question. Image formed by a convex mirror, spherical mirror. Convex spherical mirror is dash. So virtual, real, enlarged, or inverted. Option A, virtual image. In this picture, the type of image formed by convex lens is virtual and enlarged image, right? So when our object is kept between focal length and optical center, image is formed on the same side of the object, that is enlarged and virtual image. A student studies that a convex mirror always forms a virtual image irrespective of its position. What causes the convex mirror to always form a virtual image? So convex mirror, wherever you keep the object, it forms virtual image only. But concave mirror, it forms a real image as well as virtual image, depends upon the distance of object. But here concave convex mirror always forms virtual image. What is the reason behind that? Option A, because the reflected ray never intersects, because the reflected ray converges at a single point, and C, because the incident ray traces its path back along the principal axis, and option D, because the incident ray of a convex mirror gets absorbed in the mirror. So we know that, students, a concave mirror is a converging mirror, whereas convex mirror is diverging mirror. So generally, real image always forms when reflected rays or refracted rays, they intersect directly each other. But here convex mirror, since it is diverging mirror, the reflected rays, they never intersect directly. They appear as if they are coming from one origin point. They appear as they are converging, but they never converge. That's why convex mirror always forms virtual image. Option A, because the reflected ray never intersects. That's the reason convex mirror forms always virtual image. Next question. A 10 mm long awl pin is placed vertically in front of a concave mirror. Again, concave mirror is given. A 5 mm long image is formed at 30 centimeter in front of the mirror. The focal length of the mirror is. So here, if you see, size of object is given, that is 10 mm. Size of image also given, that is 5 mm long. That means the size of image is exactly half of the size of the object. It is smaller than that one. And generally, when object is beyond center of the curvature, image is formed between center of the curvature and focal length, then the size of image will be half. So here it is given object distance also given, that is 30 centimeter in front of a mirror, then focal length. When image distance is 30 centimeter, we can guess that object distance is double to it. Since size is double, size of object is double to the size of image, so distance of object also double to the distance of image here. So a focal length here. So if you use this magnification formula, that is magnification is equal to, since it is a mirror, minus v by u, that equal to height of image by height of object. If you use that formula, you will get answer for this. Answer is B. It is 20 centimeter. Focal length is 20 centimeter. Then center of the curvature is 40 centimeter. And image is between 20 and 40. 20 and 40. Then object distance must be above 40. So since object size is exactly double to the image size, object distance also double to the image distance. It can be around minus 60 centimeter, but focal length is given as 20 centimeter. Next question. Rahul conducts an experiment using an object of height 10 centimeter. Object height is given here. And a concave lens with a focal length 20 centimeter. So focal length also given. Object height, focal length both are given here. The object is placed at a distance of 25 centimeter from the lens. So object distance also given. So object height is given, right? Focal length is given and object distance. Focal length is 20, object distance is 25. That means center of the curvature is 40 centimeter. So object is in between center of the curvature and focal length. The image must be beyond center of the curvature in this case. Here it is lens is given, right? Lens is given. Concave lens always forms virtual image, remember. Can the image be formed on a screen or not? Your options are as the image formed will be real, no chance for that, because convex lens, convex mirror always forms virtual image. Similarly, concave lens also forms virtual image. So option B, yes, as the image formed will be erect. Possibility is there. Virtual means erect. No, as the image formed will be virtual. No, option D, no, as the image formed will be inverted. Right? Real and inverted is not possible. Your option is C, no. Can the image be formed on a screen? No, as the image formed will be is virtual. Virtual image will be formed. Magnification produced by a rearview mirror fitted in vehicles. Magnification produced by a rearview mirror fitted in vehicles. Option A is less than 1, option B is more than 1, option C is equal to 1, option D can be more than or less than 1 depending upon the position of the object in front of it. What is the question here? Magnification produced by a rear view mirror fitted in vehicles. Always magnification, the size of image always smaller than the size of the object, because rear view mirrors are convex mirrors. They allow us to view wide angle, right? So your answer is option A, it's less than 1, always less than 1. Magnification is less than 1. So if magnification is exactly 1, that generally in case of a plane mirror, and sometimes when object is at center of the curvature, and it is magnification will be 1. A student conducts an activity using a concave mirror with a focal length of 10 centimeter. He placed the object 15 centimeter from the mirror. So focal length is given, that is 10 centimeter. From this we can understand that center of the curvature is 20 centimeter, but object distance is given 15 centimeter. That means it is in between focal length and center of the curvature. Object will be beyond center of the curvature. Of course, sometime maybe object size also double to the object of size. Image size will be double to the object size. Now the question is, where is the image likely to form? Likely to form, right? So at 6 centimeter behind the mirror, behind the mirror. So it's not possible. When it is behind the mirror, when object is between focal length and focal length and a pole, then only image will be formed behind the mirror. It's not possible. At 30 centimeter behind the mirror, not possible. Focal length, right? At 6 centimeter in front of the mirror, maybe, and at 30 centimeter in front of the mirror. So see, when object is in between C and F, image will be behind the center of the curvature. Its size will be double to that one. Now your option is at 30 centimeter in front of the mirror. That means object and image are on the same side. Object size is exactly double to the image size. The image of an object placed in front of convex mirror. Convex mirror. Remember, convex mirror always forms virtual image. So, convex mirror is given. We have to understand that convex mirror always forms virtual images. The image of an object placed in front of a convex mirror is formed at the object itself. Option B, twice the distance of the object in front of the mirror and half the distance of the object in front of the mirror behind the mirror. Option D, behind the mirror. Behind the mirror. Convex mirror always forms image behind the mirror. Next question. A full length of image of a distinct tall building can definitely be seen using. See, there is a clue for you here. So we can see, if you want to see a full image that of any object, that image should be made smaller than the object. Generally we use many like mirrors, like for rear view mirrors, and we can use the same mirrors at buildings, at road curvings, in front of big factories, where we can see these kind of mirrors are used. They make object into smaller size. They provide us wide angle view. Your options are concave mirror, option B convex mirror, option C a plane mirror, option D both concave as well as plane mirrors. Your option is option B, it's a convex mirror. Convex mirror always makes a wider angle of the view. A student conducts an activity using a flask of height 15 centimeter and a concave mirror. So concave, he kept a object in front of concave mirror whose height is 15 centimeter. So object height is given 15 centimeter. He finds that the image formed is 45 centimeter in height. Dear children, see the ratio 15 centimeter and 45. That means exactly 3 times bigger, 1:3 ratio. So what is the magnification image? We know that formula, magnification m equal to height of image by height of object. That means height of image 45 upon height of object 15. That gives you 45 by 15, that is 15 3 times 3. Magnification will give 3 times 3. So remember, magnification has no units at all. No units at all. But since it is concave mirror generally always forms some real and inverted images, right? So your is +3 or -3, that we have to remember. Concave mirror, it's generally it's -3 times, +3 times. Object is, that is 3 times bigger than it. So 3 times bigger. It's a magnification. 3 times bigger. Which of the following can make a parallel beam of light from a point source incident on it? Parallel beam of light from point source. Option A, concave mirror as well as convex lens. Option B, convex mirror as well as concave lens. Option C, two plane mirrors placed at 90 degree to each other. Option D, concave mirror as well as concave lens. See the question here. Observe the question carefully. Which of the following can make parallel beam of light from a point source incident on it? From a point source incident on it. Your option is option A, concave mirror as well as convex lens, that makes a parallel beam of light from a point source incident on it. Question. A student studies that the speed of light is in air is 3 lakhs kilometers per second. 3 lakhs kilometers per second, right? whereas that of speed in glass slab is about 1,97,000 kilometers per second. Kilometers per second. What causes the difference in the speed of light in these two media? Option A, difference in density. Option B, difference in temperature. Option C, difference in the amount of light. And option D, difference in the direction of wind flow. So see here, when object moves from one media to another media, it refracts generally. When object moves from air to liquid, it refracts towards normal. When object moves from liquid to air, it go away from the normal. That means refraction depends upon density of light. So the speed of light is more in rarer medium when compared to the denser medium. Here air is rarer medium and whereas glass slab is denser medium. If density is more, speed of light is less. That's why in air, since it is a rarer medium, whose speed is 3 lakhs kilometers per second. But since glass slab is high denser, its speed reduced to 1,90,000 97,000 kilometers per second. So obviously the speed of light varies on density. Your option is A. Option A, density. Yes, my dear children, these are the 20 questions that we have discussed today. I think you have all gone through clear this one. If you have any doubt, please send a message. Thereby, I will try to clarify your doubts. If you like this video, please share it and subscribe it. Thank you. All best for your upcoming exam.